I'm going to be talking about testing in general, and also some tricks that you can apply in Elixir to make the testing more maintainable. My name is Daniel Caixinha, and I'm a software engineer at Onfido. In case you want to reach out to me later, this is my handle at GitHub and also in the Elixir Lang Slack channel. So before I jump in, I'd like to give you some context so that you know where I'm coming from, and also why I will be focusing on comparisons between Ruby and Elixir. So I started shortly after graduating. I joined TalkDesk, and I was really lucky to have the chance to learn with top-notch engineers day in, day out. I complemented that knowledge with so reading a bunch of books, watching a bunch of talks, and started applying the patterns of gurus of the community like Dave Thomas, Andy Metz, Uncle Bob, and others. And eventually I got to a point where I felt really confident about my code and the code that I had developed, but both the code and the tests. So I felt really confident and proud. And then upon joining Onfido, I had the chance to Elixir more seriously. So eventually I got back to square one, because everything is really, not everything, but most of the things are really different. Yeah, I got the chance to actually use it in production. I had heard of it, like played around with it for a bit, but never had the chance to actually use it. And yeah, I battled with the changing paradigm for a little bit, but eventually I felt productive in Elixir as well. However, the testing part took a bit more time to feel the same level of confidence and pride in my tests that I did in Ruby. So a small disclaimer, the things that I will be talking about here only apply to XUnit, the XUnit framework for testing. There are others in Elixir. So for instance, the first project that I picked up when starting in Elixir used the eSpec framework, which is like really similar to the RSpec framework, has an API that's almost the same. In that sense, I moved to Elixir and started writing tests in the same way, since the API is really similar, and everything was working well. But this always felt like it wasn't the Elixir way of doing things, and it became really evident when I needed to create mocks in my tests. This started to feel wrong when doing this. So. I believe that the clash that I felt in this change to Elixir is partly explained by the difference in philosophy regarding testing from the language that I come from. So in Detroit School TDD, which is like the classical TDD that's applied, it was applied by Kent Beck in the 90s, and is the classical TDD. In this type of TDD, you try to maximize the regression safety net that's provided by the tests, and you do that by minimizing the use of test doubles. So in this school of TDD, you minimize the use of test doubles and maximize the regression safety net. On the other hand, on the London School of TDD, or as Martin Fowler calls it, the mockist approach, you focus singularly on the subject under test. So you mock every dependency and you focus just on the code that's being tested. So this approach leads to a higher design feedback, because you have to deal with all the dependencies from the subject under test. And usually the tests that come out of this approach are what people call true unit tests, because you have all the dependency isolated and only the code under test is running. However, the one disadvantage of this approach is that you have to complement this with the integration tests to make sure that all the small parts are glued as they should. Otherwise, you can have all the tests passing and production on fire. So regardless of the school that you follow, or if none at all, you will need to, there are some universal rules that apply to unit tests. These were defined by Michael Feathers some 12 years ago, and basically states that a test is not a unit test if it talks to the database, it communicates across the network, touches the file system, it can't run at the same time as any of your other unit tests, and if you have to do special things to your environment to run it, such as editing a config file. So eventually you'll need to create mocks, and what I'll be talking about here applies regardless of the testing school that you follow. Here, I'm sorry for the theme that I chose because it's not really displaying well, but here you have some pseudocode of XUnit. So you have basically two describe blocks. And you will notice that the setup phase of these blocks have a similar setup. So they call a function called address already validated. In case you are not familiar with this syntax, basically the setup is a list of functions that you will call to set the context for that test. And what most people will do when looking at like this snippet of code is trying to remove the duplication and basically isolate that setup phase on an outer context that will include those two. So basically, what I try to follow when writing tests is the damp not dry principle, which states that in tests you should not follow the dry principle, the don't repeat yourself, and you should instead follow the damp principle, which means descriptive and meaningful phrases. So one argument that comes like regularly when discussing this is that test code is still code, meaning that you have to like take the same care and apply the same principles to it because test code is still code. But actually what I like to think is that test code is untested code. So what I try to do is I try to make it as simple and dumb as possible and maximize the descriptiveness of it while minimizing the logic and the magic inside it. So basically, in XUnit, this descriptiveness and the lack of magic is actually enforced because you can't have nested describe. So if you wanted to apply what you could use in RSpec, for instance, which is to like have an outermost block of describe, having like when the address is already validated and then have the two blocks inside it, you can't do this in XUnit because there are no nested describe blocks, as I've mentioned. So basically, this is, and José Valim, as most of the things in the language, he discussed this in the Elixir forum. And the reasoning for this is that, like, when you start to have nested tests, they become really unreadable, and you have to like figure out and navigate through a stack of nesting contexts to figure out what the test is actually doing. So this can seem like harmless in this simple example, like why don't I just put those two inside the other one? But as your application gets bigger and bigger, this becomes really painful, and I'm sure most of you have felt this pain of jumping into a new Ruby application, jumping into some tests, and then trying to figure out what's going on. And yeah, you start to just go up the stack of nested contexts, try to put things in your brain, but then there are some contexts that don't apply to your test because they are at the same level, so you have to jump over that one. And this is really, like, this is such an hassle. This is really hard for the programmer to immediately know what's going on in a test. So coming from the Ruby world, Sandy Metz was naturally a high figure in my world, and in her talk, the magic tricks of testing, she basically came up with this matrix, which describes how to create tests that aren't redundant. So if you haven't watched this talk, I highly recommend it, even if you don't come from the Ruby background, because it's general enough so you can understand the concepts behind this. I usually try to keep this matrix in my tests, in my head while writing tests. So what I will do is go into each one of these cells on this table. So basically, she broke down into queries and commands on the top, and then based on the origin of the message that is flowing. So either incoming, sent to self, or outgoing. So the sent to self one are to ignore totally. But I will be focusing on the other three. So I'll start by the incoming query. So in an incoming query, you need to assert the result that comes back of the function that you are testing. So this is the simplest example. So I have some code here, some codes that I've created just to exercise what I'm talking about. So imagine this module is responsible for validating addresses. So you have at the top the behavior of this module, then a couple of functions like the validation level and set validation level that we will not be using for now, but basically just read and write things to the application config. And then the validate function, which is what we'll be testing now, which receives an address and validate that it has less than 32 characters. And also emits an event, but I will ignore that for now. So basically, it gets the address, gets its length, and uses pattern matching below to validate the address. So the approach to test this, as I've said, it's the most simple one, is just run the function and assert on the outcome of that function, or on the return value. So basically, when the address is fewer than 32 characters, we are pattern matching this to true. Otherwise, when the address is a really long one, longer than 32 characters, we are pattern matching to false. So yeah, this is a really simple example. I'll just move on to the next one. So in an incoming command, we want to assert on the direct public side effects of that command. So basically, right now we'll be testing the set validation level, which is our incoming command. So in this case, we will observe the public direct side effects of this by first running the function under test. Then the validation level is the one that reads the current config value, and this is the part of observing the public side effects. And then we will assert on that the validation level is the one that we have just written. So basically, this one was really simple as well. The two on the top are really simple because they don't involve mocks at all. It's just usually simple to test these kinds of functions and modules. But now I will be talking about the outgoing command. So in this case, we are expecting to send something. And this is where it gets a bit trickier and where I spent most of the time getting right. So how should we test this? There are a huge number of ways to approach this. I'll be talking about some, but yeah, basically this is the one that requires mocks for, as I've said. So this is the same code that I've showed you before, exactly the same code. So the first step is, as I think most of people would guess, is inject the dependency. So we are testing that the init event on the validate function gets called. So we are testing that the outgoing command gets called, otherwise we are not testing for the right things. So this is done by the demo event emitter module here at the bottom. So the first step is actually inject this dependency. So we are getting the event emitter from the application config and then inject the dependency here below. This will allow us to inject in the config test.exs. We are injecting a different one in the regular way of the application working. You just inject the real one. So here we inject this event emitter mock. And the code for that is this. So at the top is the behavior of this module. then we are defining the function that we are mocking. Basically, as you can see, we are sending a message to self, so to the current process. Then we are just returning OK to keep the contract of the real module as the behavior defines. But yeah, basically we are using messages between processes to ensure that the thing that we want to get, to ensure that the thing is being called properly. So the testing code for this is really simple as well. We just run the function, and then we use assert receive to assert that we have this message in our mailbox, so the mailbox of the current process. Yeah, and this is a really simple code, but sometimes it can be a bit overwhelming, and afterwards, after you go through the journey, the code is really small and simple. But this approach is simple, but it stops working in a number of cases. One of which is when you have the code under test spawning a new process. So the function that we are testing spawns a new process inside it. So this is very common in Elixir. For instance, if you use the pull boy, which is a worker pull library, essentially you are spawning a new process, and you can use it for a different number of reasons. But for instance, if you want to limit the concurrency that your application is providing, this approach stops working. So what I usually do in these tests is basically we change the event emitter mock, so this module, and we turn it into a gen server. So basically we start the gen server with the state of an empty list. Then we have two new functions. So the handle call with the subscribe, and the send to listeners, which is this private function below. So the handle call with the subscribe basically is the function that will register a certain PIDs to the list of PIDs that we'll be sending our messages to. So basically, we subscribe a certain process. Then when the emit event comes, we use the send to listeners function instead of just sending to the current process. This code is really simple as well. You just, then on the send to listeners function, you just iterate over for each listener in the listeners list, just send this message. And yeah, this approach starts to work with just minimal changes to the code. Basically, you just, in the test, the testing code is exactly the same. You have to just set up the subscribe. So we'll run the subscribe before running the test. And the subscribe, if you were using pull boy, would be something like this. So we would call the subscribe with the self, which is our own process ID, and the test would continue working. There are a couple of issues with these approaches, both this one with the gen server and the other one with just the current process ID. The main one is that the testing code is spread out across the different files. So basically, you have the test, you have this test, and this test, the code that's being exercised on this test is not really clear just by looking at this file, because this is split across multiple files. For instance, the event emitter mock, which has the logic of getting this. So there are a couple of issues with both approaches. Pretty recently, there was this new library called mocks. It was created like less than 2 months ago by José Valim. And basically, as he describes it, mocks is a library for defining concurrent mocks in Elixir, which is really interesting and solves a bunch of issues that I felt with testing. So basically, there are some principles that Valim defines. So there are no ad hoc mocks. You can only create mocks based on behaviors. So you can't just create a shallow mock. There are no dynamic generation of modules during tests. Mocks are just defined in your test helper or in a setup block and not per test. So concurrency support, tests using the same mock can still use async through, so all the tests run parallel. And rely on pattern matching and function clauses for asserting on the input instead of complex expectation rules. So this means that we will use pattern matching instead of like those long clauses in our spec with expect certain mock to receive X with, and then the arguments that you want. And how would we adapt this to use this mocks library, the example that I gave you? So the first step is to declare it as a dependency, test dependency in your mix file. Then, as Valin advises, you will define in your test helper the mocks that you will be using, and also link them to the actual like production module that this mock is for. This will assure that the mock will always respect that contract. Yeah, basically it's just this, the configuration, and then the code itself on the test. Basically, what changes these two lines on the top, we are saying that for this mock, so event emitter mock, we are expecting to receive the emit function, and basically the second argument is a lambda function that will run once this mock gets this function call. So this just immediately brings some pretty good like advantages. One of which is that you have all the things that are running in your tests in line with the test, and this becomes really much more readable. So basically, we will still be using the same mechanism, just the send to self and assert receive, but much more readable. Also, I didn't mention, but the setup on the top is verify on exit, which just instructs the mocks library to verify that all the expectations that we defined in this test were ran, but basically those function calls were made. And yeah, this is basically it. There's an interesting point is that, for instance, right now in the lambda function, I'm just using an underscore because I don't care what gets passed to that function, but you can use pattern match on this. So if I expect the init event to be called with validate address, for instance, I can pattern match on it, and this way the test will only be correct if the function call is made with the right arguments. So there's a caveat that I have to mention. As José Valin states, the first principle of the mocks library is that there are no ad hoc mocks, and this remains true whether you are mocking like a module on your application or whether you are mocking a library, so like a third-party library that you are using. And this can become like a bit of a pain, because you basically, if a library is not like implementing contracts, so isn't implementing the behavior, you won't be able to use mocks to mock that external library. However, this brings me to this very famous quote from the London School TZD, which is, don't mock what you don't own. And this phrase is a bit counterintuitive, but what it actually means is that it's counterintuitive because you want to use mocks because you want to mock the things that you don't own, so like external calls, etc. But what this actually means is that you shouldn't rely just on a mock for the things that you don't own. So, and this is exactly what Valin is defending here and enforcing in this mocks library. So basically, giving an example which makes this a bit more clear. If you're using the X-Twitter library to access Twitter, for instance, and the X-Twitter library doesn't implement behaviors, you won't be able to use a mock on it. And what you should do instead is define a wrapper module around the X-Twitter library, and that wrapper will become the contract of what your application expects in terms of the Twitter library. So this will most of the times be a subset of the functions that library defines, and this can be as simple as just having a module with the def delegate, and this can become a bit, this can seem a bit like redundant, but this is really important to actually define the things that your application depends on. So yeah, I'm just starting to transform my applications to do this, but it's really good because you have like the explicitness that that Valin is going for here. So some conclusions. Tests are not just about regression safety. So do use the feedback that TDD and even if you are not using TDD and just write the tests afterwards, use the feedback that come from the tests to improve your application. Like most of the times, I would say that problems in testing a certain module are not resolved by changing the test code. They are resolved by changing the production code and changing the architecture of your application. Secondly, write your tests as simple and straightforward as possible. So basically follow the damp not dry principle. Your future self will thank you, because when you come back to a project 6 months afterwards and you basically, if a test is really magic, you won't understand anything, even if you were the guy writing it. Last but not least, when creating mocks, do it based on behaviors. So basically use the mocks library, and this will ensure that both of your production modules and your mocks don't drift away, and their API doesn't drift away. And this in turn will ensure that basically you don't have all the tests green and production is on fire, as I said earlier. Allow me just a couple of shameless plugs here. So I'm co-authoring a book in Elixir called Mastering Elixir, which is coming out in 2018. So yeah, more news on that soon, but it's still in an early stage. And also Onfido is hiring. So if you love Elixir, or if you love like tackling interesting problems, or if you just love mechanical keyboards, we also have an in-house expert for that. So head over to onfido.com/careers, or come talk to me after the end of this talk.
Oh, cool, thank you for the presentation. So I'm a bit of an insider because I work with you, but one of the things I would like for you to, like this mocks thing, we haven't discussed this yet. So on your journey, like from eSpec to XUnit, and then the different settings that we had for testing, was it too hard to reach kind of these conclusions? Was it like a hard process, or did this came naturally along the way you were building different projects and applications?
Yeah, that's an interesting question. So I think that like there are like lots of material, like blog posts, books, and everything around like the changing the paradigm from like OO to functional or whatever. But I've kind of felt a lack of material in regards to testing, and in that sense, it was a bit hard to just. I basically was fetching like little bits of information from a certain parts, but they are not like. I don't think they are, and that's mainly why I gave this presentation and came up with the idea of doing this. But yeah, it was kind of an hard journey because I was really used to the mindset of RSpec, and yeah, this is somewhat different. Yeah.
In your experience writing tests like TDD in production code, what's the approach you have, for example, for doc tests? I mean, when you're trying to developing like test-driven development, do you usually like start creating first the test file and then go to the doc test? I don't know if you write doc test, if you like to write that. I'd like to know what's your thoughts on this approach between this balance between doc tests and the test files per se.
Yeah, good question as well. Actually, I usually don't write doc tests, but that's not, I don't think they are bad per se. I'm not used to it, so it's not in my flow yet. So my usual approach is write the tests, and as you would in any other language. So doc test is not still on my on my flow of doing things. But yeah, it's something that I want to start to incorporate a bit more, because it's a really interesting feature of the language. But yeah, I don't have it in my flow, and usually I just write the test first, as you do in Ruby. and yeah, leave the doc test for later.
Yes, that's because I feel this. I just have started project in Elixir, but when I'm trying to test-driven developing Elixir, so I don't yet found a balance between like, because I understand that doc test is when we are trying to write documentation and you create those assertions, and then you have tests. So yeah, my feeling is that sometimes I feel the same. For me, it's a bit difficult to do test-driven from documentation.
Yeah,
so
yeah.
Usually I write the tests on the test file, and then afterwards if I decide to write some documentation, then I create the doc.
Yeah, same approach as mine, totally.
I have a question. Have you found in your work or in your side projects or something any role for property-based testings, like the new library stream data that has been published by José Valim and some other guy, as opposed to library testing where it's obviously useful, right? Because if you have a library, you usually have some general properties you want your code to follow. But in real application code, have you found them useful or just?
I haven't like written any tests with like a property-based test. I have watched some talks on it, and it seems really interesting. I think it will come out in Elixir 1.6, and that's something. It will come out as part of the language, it's something that once that comes out, I will start exploring more. I haven't found like the time to actually dive into that, because it's really a different mindset that you have to test that. But I haven't dug into that, but it seems a really interesting approach. And yeah, once Elixir 1.6 is out, I will definitely explore that.
Yes, because my problem with sometimes with property tests is that the example you gave of the addresses having to have less than 32 characters or something like that, it doesn't even make sense as a property test, because you'd have to write a function that writes addresses with more than 32 characters, and then they would fail, and then you have to write a function that generates less than 32 characters, and it looks more complex than the code itself. So basically you're writing a test that's more complex than the code you're testing. That was just why I asked, but since you've never used it, then
can't really useful.
Thank you.
For a guy who comes from Ruby and starting in Elixir, how much of your brain do you have to turn off? Your Ruby brain, do you have to turn off? Like, how much of it is it's an advantage, and how much of it is an advantage?
So I mean, it's kind of a rough journey, because for me at least, like for countless times, I would be in Elixir trying to like update a certain key in a map, like directly, and only to find out like some minutes later that I was being dumb, and this would happen, and I would hit my head against the wall, and eventually you will learn it. And yeah, it's as learning anything. You start reading, you start understanding like how things are structured and why are they structured that way. So it's kind of a shift in many aspects, and I wouldn't say you have to turn off your brain. I would say you have to update your brain, but your Ruby brain, that's kind of, in that sense, in the sense of mutability, it was a bit hard, but in the sense of like object orientation, actually Elixir is like more object oriented, in the sense that you pass messages between processes, and that way it feels really natural to write like applications in that way. So the calls are non-blocking, and you have like a bunch of messages between processes, or if you can see him as objects, it's the same thing. It's like what Alan Kay described in the beginning. So in that sense, in the sense of like object-oriented mindset of trading messages, I didn't have any like hard time with it.
I have one question. Don't you feel like it's sometimes inevitable to use the library mock, which is based in Mac? Like, for example, when you are communicating, for example, with RabbitMQ, and you have a library like
MQP.
Yeah, and you need to like you want to mock it, but then the behavior is really something very tough to write on your own because the library doesn't use one specifically, and to do all that work, don't you feel like sometimes it is inevitable you use something like that library, mock library, and you don't follow these like not directive but philosophy of Valim?
Yeah, so in the beginning, I used that mock library, and yeah, I just needed to just continuing shipping stuff, shipping stuff, and I would use that mock library. But like as I've said, this came out like pretty recently, so I'm just in the process. But I don't think there is such a case where you are like forced to do that. I think you have really to like change the architecture, create those wrappers, define the contracts between your application and your dependencies. And in that way, I believe that like you define a contract and then you in the tests, your code becomes really small and really simple. You have to, yeah, you have to have the trouble of creating, and this is a bit cumbersome, yeah, but what, like it's an investment, I believe, and I believe that you will be, it will pay off in the long run, because yeah, you won't be creating mocks like one-off mocks, and it's a small like buy-in, but I think it's definitely worth it.
Hello. Two questions. The first one, like you, as you said, you come like from object orientation, like Ruby background. Do you feel more safe about the code you write using a functional language as Elixir? Number one. Number two, if you ever considering going back to a language that embraces mutation of stuff.
Yeah. So answering the first question, so yeah, definitely like immutability is something really powerful, and I do feel way safer than I felt in Ruby. So there are some cases where I actually like felt that like extra security in not having mutation, and this happens everywhere. So if you there's never like copy between, there's never shared memory between processes. It's like it's everywhere in the language, and in that sense it's really good, because yeah, if you send a message to another process, that new process will never mess up your own stuff, and in that way I did feel really more safe, I would say. I'm not like, I don't have any example at hand, but I did feel that. Regarding the second question, I'm not. I don't think I will be coming back anytime soon. Like our company still uses Ruby, and as all startups, we have a monolith which is really pretty. And sometimes I have to come back to Ruby. And yes, basically every time I have to come back to Ruby, I basically feel that I feel that I'm programming without an arm, because there are some things that I'm just expecting to have which I don't have anymore.
But
like,
probably your Ruby code has improved a lot. Yeah,
for sure. But there are some things that you like take back to each language you will be writing on. So your Ruby code improves, but unless you take really work and use libraries to have immutability everywhere, which you probably won't do in an application you don't know so well, you apply different patterns, but the language and the runtime is not the same. So yeah, thank you.